Hello and welcome to today's webcast on game-changing use cases in healthcare and life science, brought to you by Insight and AWS. Below this webcast, you will see an attachments tab where you can navigate to after this webinar and find additional information on assets regarding today's topic. I would now like to turn over this presentation to our speaker, Karim Taglianti, Insight's Chief Data Officer. Karim, the floor is yours.
Thank you, Carter, and thank you all for attending today's session. So I'm excited to talk to you today about game-changing AI and the use cases in healthcare and life sciences, along with our partner, AWS. So first of all, let's talk a little bit about preparing the business today and tomorrow. And so we all know that AI is a disruptor. Clearly, it's disrupting all of our business areas, and I want to talk about healthcare and how this works. So in general, we're all thinking about how we can take advantage of generative AI across the board. All of humanity actually is thinking about this as well. But there are many, many use cases that have been identified and certain areas where we're seeing a lot of traction. And so healthcare is kind of at the bottom of this list here, but in general, there's still a lot of uptick in terms of what it is that we're doing. And so if we think about healthcare in the context of things like even for marketing and advertising as it relates to the services that are provided by the healthcare facilities, these are important areas to focus. And then being used in the technological sense, it's also very important in terms of, say, data center management or cloud management or infrastructure management. And so there's a lot of opportunity then in the space. And so these are the areas that we'll be talking about today. So we all know it's important. We all know that it's something that we have to do, and it's really not anything that we can ignore. So we want to embrace this capability and then understand how we can apply it within our arena to be able to make ourselves more operationally efficient, or even to create better service for our customers, or even competitive advantage as it relates to that as well. So here, we'll just talk about the generation of, or the how AI has evolved over time, or I'll call it I don't want to use the word generation too frequently, but in general, we've evolved from artificial intelligence, which was defined in the 1950s. We saw the evolution of machine learning being more algorithmic techniques where we could learn about how our data could be used to predict future outcome. And then we also started moving into this sort of mimicking human intelligence through deep learning or artificial neural networks, as we thought about how can we learn more about the behaviors that are captured by the data assets that we have available to us. And so that really led to what we see today, which is generative AI. And so generative AI is really just a special case situation as it related to deep learning in terms of understanding the corpus of knowledge which was available through the internet or extremely large data sets, and then understanding how it is that we can take human language and then understand the representation of that language to be able to do things like answer questions, understand semantic content, and to be able to create bots or query response environments. And this is the world we're living in today. So it's not so much that classical AI techniques are no longer used or applicable. It's really just how do we take advantage of the new generation of these generative AI techniques, which are really more focused on human language understanding, but also multimodal approaches to being able to think about human interaction through language, which is our most popular, but also through visualizations and visual techniques. And I'll even add to it speech to text, text to speech. So these multimodal concepts are starting to become more popular as we drive forward, and we'll talk about how we can do that. Now, what we've seen over time as well is, like, we talk a lot about large language models. So that's great. There's lots of models. ChatGPT was the first one on the market, of course, and everybody's very familiar with that. And OpenAI sort of led the charge here. But now we have a lot of community models that are made available. There's a lot of big organizations like Meta, for example, produces their own models, and others. And so there are many different models to select from. And so this is something that you need to think about as well as you move into the space and really think about how it is that you can take advantage of these capabilities and techniques. There's not just one solution. And so making sure that you can take advantage of the one that's most appropriate for you in your business is going to be critical. I talked a little bit about this already, but what's the difference between, generative AI and classical techniques? Well, within this context, the foundational models are trained on a significant amount of data. So here, it's kind of thing where you aren't going to just say, take your data that you have within your own organization or healthcare facility and then create your own model, because you need a lot of data in order to be able to train the model to understand tasks and behavior, which is really what these large language models are good at. So you typically see them provided as services or potentially even as open source language models with the weights included. But it's usually the training of them costs or may cost, tens of millions of dollars to be able to do this. Not the kind of thing that any healthcare organization, for example, is going to do just quickly or without spending a lot of time thinking about the actual value they're going to get from it. So there are techniques that we'll talk about that are more applicable within the healthcare space that provide a lot of value to us. But that's the idea, was these were trained on extremely large data sets so that they can be accurate and more precise. And we'll also talk about maybe some ways they aren't so precise, like in the context of hallucinations. We'll get to that too. But they're customizable. So these models are trainable over custom data sets. And we'll talk about different strategies that we can apply, which include things like RAG-based models, response augmented generation, or training models, which is what I talked about earlier, training them from scratch, or tuning models, which is the third type. And any one of those types can be applicable depending on what your objective is. Also, there are more general, so these models are trained on a broad range of recognition. So again, multimodal concepts, they could be text, images, or music. So this is really, we have to make sure that we understand the particular use case and then apply it in the most appropriate way. For example, within the healthcare industry, a lot of what we work with is related to imagery. It could be CAT scans or radiology or other kinds of images potentially that are used to help us to understand how to provide the best patient care. So we may actually want to integrate with different types of knowledge in order to be able to create more benefit for us overall. So one of the biggest use cases, which I'll get into as well, is really focused on just understanding or explainability. So it's we want to make sure that we can say, look at an image and then understand how to interpret what we might see in the image in a language that's easy for the user to understand. So it could be, if you're a doctor, it will talk to you in terms that are related to the doctor, or it will translate the generative responses in terms of, say, the lexicon of a doctor or the ontology that they typically speak in. If it's for maybe a patient, we can provide information to a patient in a language that's understandable to them. So this is really an important concept overall as we think about the applicability of this environment. And it's also accessible. So we've seen, again, with just ChatGPT, prime example, a simple interface allows you to take advantage of this powerful concept, and this will continue to proliferate. We see it now all over the place. You can access AI from just about anywhere these days. So you're seeing it built into all kinds of applications, and it's really important to understand the model. And we'll talk a little bit about this too. So the impact on the workplace, including the healthcare industry, is, well, first of all, productivity. We're trying to, we always are challenged with lower budgets, and we're expected to do more with less. And so productivity is going to be really important for us, or maybe even it's increasing patient populations and we just can't hire people fast enough. So we have to think about how can we create productivity in light of the fact that we have either limited resources or we don't have the budgets in order to be able to support it. So in this context, we can then say, look for opportunities for enhancement. But clearly the disruption has happened and we are all responding to it. So here it's taking a look at how do we take advantage of these techniques and capabilities in order to keep up with the rest of the world, but also now it's also to provide the best value to our patients, to our constituents. And then, of course, as employees, we look at it from the perspective of how does the workforce change? What are the shifts in terms of how we integrate or react to some of these new features and capabilities? And then, there are cultural elements of this that are applicable as well. Okay, so what are some of the top generative AI use cases within the context of healthcare? And this is what AWS is seeing. So, as well as Insight. So we see this in addition. So one of our key partners. So clinical workflows, primary area. So basically clinical notes, capturing the doctor's voice as they are taking notes, or even with, of course, permission, recording conversations that they might have with the patient, for example, or during surgeries or maybe other opportunities to be able to understand what are some of the things that are said or capture them so that they can be transcribed and used for better, more efficient healthcare. Summarization, of course, is one of the use cases I talked about. I'm not going to read these all to you, but in general, you get the idea. So any place where you may use or you could take advantage of language, and it is of course, the way that we all communicate, especially in this healthcare field, because we interact with patients, we interact with other doctors, we interact with these, within the context of our medical teams. We have to be able to communicate. We have to communicate to the insurers. So there's a huge ecosystem of communication that's required. So having the ability to do that in the most effective and productive way possible makes this a really important area for us to focus on. So as I was talking about before, so summarization really has to do with sort of creating convenient analysis of maybe the interactions that might take place. Care management, it may have to do with maybe we can do things like understanding classifications or segmentations of the population. Patient engagement, another big one. So basically talking in patient-friendly lexicons makes it easier for us to understand what is the patient interested in, how to perform things like question-answer techniques. So like even bots are really great for patient engagement or explaining things in terms that they understand more effectively. And sometimes, there is that impedance mismatch between what a doctor might say and what a patient understands. And then educational research is huge here because there's so much work that's being done in the academic circles, teaching hospitals, or within other areas in order to be able to communicate information, and even for doctors to keep up with what's happening instead of reading 3,000 papers a week, which I know is a little bit facetious. But in general, there's a lot of knowledge and information that's being communicated with, especially in healthcare. So how do we make that accessible? How do we create summarizations or understand the most relevant parts of maybe academic research that's being performed in order to be able to help us to perform better within our patient care or in our engagement strategies with patients. So there's a lot going on here in that space as well. And the last one is really just operational. So every healthcare organization has IT groups, IT teams, and so we also want to make sure that we are providing access to the correct set of information, whether it's integration into Epic systems or other clinical systems. This is really an important part of making sure that we understand how to do that. So these use cases are prevalent throughout the space, and this is how we also want to engage and make sure that it becomes more straightforward in terms of how to do this. I reluctantly or don't want to use the word easy, but it certainly should be straightforward because none of this is easy at the end of the day. And so in general, so as I was talking about, there are facilities that allow us to be able to do this better. So relying on technology makes it really important for us because we don't want to have to reinvent the wheel. Now that we have defined that generative AI can provide value to us, we also want to make sure that we understand how can we take advantage of these capabilities without, again, say hiring a staff of data scientists in order to be able to create a model so that we can start from scratch. That's not what we want to do. So what we really want to do is take advantage of services like Amazon Bedrock, for example. So now Bedrock allows us to be able to create the environment that allows us to realize those use cases that we just described. So we can integrate or use foundational models, the models that I was describing a few slides ago. We can take advantage of those models and use them to be able to create the type of interaction that we expect in order to either create environments for, say, patient learning, for patient interaction, or for medical care practitioners to be able to learn more about maybe what's happening in academic circles, or even just to understand the behavior within our own clinical practices or healthcare practices in order to be able to optimize more effectively. So the other thing that's important is performance. And so, we want to ensure that we have SLAs that are met. So, and we have different mission critical applications. So we clearly don't want to, create an environment for, say, patient interaction when we're, waiting 35 seconds every time when we ask a question for a response. That makes no sense. So we want to make sure that we have the performance, and certainly Amazon Bedrock allows us to be able to do that effectively because it's running on within a managed services environment, which gives us the performance that we would expect. And because it's a managed service, it's dynamically scalable. It allows us to be able to take advantage of the vast amount of computing power and capabilities that are available within the Amazon ecosystem. And of course, powered by Gen AI, as we've been talking about, and flexibility to build. So now we can either build our own foundational models or interact with them and build our applications around them. So that's going to be certainly important. So how does it work? So basically, we use the Bedrock Foundation to be able to define the large language models we're creating. We can access the top foundational models based on sort of the selection from Hugging Face or others in terms of what those models might look like. We can customize with our own data by using things like a RAG strategy or tuning capabilities. We connect to our data sources, especially in the context of, and RAG stands for Response Augmented Generation, but it allows us to be able to customize our experiences with our own data. So we build our own knowledge base, and that's what we use in order to augment these models. And then it enables us to be able to perform tasks effectively. So whether the resultant task is, like I said before, patient interaction, or maybe it's learning or processing, in order to be able to identify optimizations, whatever the task might be, so long as it's fundamentally related to this concept of language interaction, this allows us to be able to take this to the next step. And that's really what it's all about. So one of the concerns always for us, especially in this case in healthcare, is about keeping our data private and secure. And so we want to ensure that if we're using Bedrock or using the AWS ecosystem, we know that our data is being kept private. So there are supports for standards, including HIPAA, GDPR, et cetera, in order to be able to ensure that we're keeping our data private. And so basically all data is encrypted at rest, which you would expect through private link support and the APIs as well. So we basically are not exposing the data to the external internet. VPC endpoints really just means that so long as you're within your own virtual private network or virtual private cloud, you never leave it. So you don't have to worry about external exposure unless you are intending on external exposure, but it's basically at least you're trying to expose as little data as possible. Customer data isn't used to train any underlying models, so anything within the Bedrock platform, any large language model you might access, is going to be kept private. You keep it private within your own tenant. Nothing is exposed externally, and it's not used to train data. Now, you may want to keep some of that data yourself because you might use it to be able to understand behavior. So you might say, well, in this particular case, I want to know what those interactions look like because we'll get to this in a little while. But in general, you want to ensure that you have the ability to also learn yourselves for your own business, not for the general population, but how can you make the applications of the large language models for your own business purposes more effective? And so being able to know which prompts have I used, which prompts were the ones that I expected, what worked, what didn't. Those are the kinds of things that you want to make sure that you capture, like any application or any application of technology within the healthcare arena or environment. These are the things that you would typically do. And so that's, this is supporting the same model. And then customized foundation models that you can use. You can perform things like either tuning models or creating your own, et cetera, and then making them available through the platform. So it's a very robust platform that allows you to be able to take advantage of these capabilities without, again, being experts in the field or hiring PhDs in order to be able to perform all of these activities for you or build them from the ground up. So the other thing that we also want to talk a little bit about is making sure that we're using best practices as we think about healthcare solutions, but also using AI in this context. And so technology we've talked a lot about. But in the general sense, learning motivated is really an important part of this because we want to make sure that we're not relying on these kinds of environments. And I'll talk about this with human focused, which is another pillar. But in general, we want to ensure that it's a mechanism that allows us to become better at what we're trying to accomplish. So we're not replacing the doctor, we're not replacing the healthcare worker. What we're trying to do is we're trying to make this a better experience, make it more effective, and make the humans that are involved in this process more adept at doing their job. And that's really what this is all about. And so you can see this happening, especially in the use cases that we talked about. An important part about doing that as we think about it is to, critical thinking is a big part of that. And so explainability is going to be a really important part of it. So why did the response come out the way that it did? Well, we want to make sure that we understand that, the research that went into creating that particular response was one that makes sense, number one, or number two, is verifiable by, let's say, academic papers or documentation that is available out there, especially in this context, life or death situations or recommendations. Clearly, we want to make sure that we have the ability to explain how this response was generated, or before we can make a recommendation, understand how it was derived. And that's really super important. Robust and scalable. These are two areas where AWS is really, this is their bread and butter. This is where AWS has been since the early 2000s when AWS first came onto the market. But basically, it's creating environments that are resistant to errors, that can, you can ensure that they're up and running, they're highly resilient and scalable and elastic. And this is really what this is all about. And those pillars are super important as well. And then responsibility, of course, we're still working through some of these things, as we're all well aware, especially in the healthcare space. But what data can we use ethically, and which data needs to be protected, or what kinds of controls and constraints might we put in place in order to ensure that we are using data in a responsible and effective way, especially as we think about patient information, patient care. So these are important parts to think about, and it's really a good approach in terms of how we want to think about it. So what are some of the challenges that we think about here? Of course, well, we have technical challenges, ethical considerations that I just talked about, and there are even organizational barriers. So there's cultural changes that are part of this as well. So it's, within any organization, because we're in a disruption, I'll call it, what happens is that the culture needs to change. We need to adopt new technology. We need to think about things in different ways. And so this is really, sometimes it's a cultural change that needs to take place in order to take advantage of these new capabilities. Okay, so generative AI healthcare solutions, let's just talk about a couple examples that might make sense in terms of like how we apply some of this, because we can go all the way off to the I'll call it the right side, where we think about the singularity, or AI that takes over the world. Well, we're not even close to being there. So, but there are, lots of AI capabilities that we can take advantage of today. And that's why we want to talk about what are some of those things that we can do today. So there are AI capabilities like TextTrack, for example, where you can extract information from structured, unstructured medical documents. So basically, having an AI infrastructure and allowing you to be able to analyze them using TextTrack is one way to take advantage of providing AI capabilities to solving your problems within the space. Comprehend Medical, for example, is it links to standard ontologies that we're all familiar with, ICD-10, RxNorm, etc. And so it allows us to be able to link or understand what is being documented within the context of these lab reports or claims, or other kinds of documents that we might analyze, and then understand how it applies to the ontologies that we're looking through. And then HealthLake is effectively here. This is really a protected version or HIPAA compliant version of the I call it a data lake, which allows us to be able to store patient medical information, patient healthcare information in order to guarantee that it's kept private and complies with HIPAA regulations and statutes. So there's lots of things and services that we can take advantage of, and we tie them all together. And so if we take a lot of this information and then sort of bring it all together, we can summarize and interact with healthcare documents, for example. So here, just sort of a simple architecture. We don't have to go through the entire architecture, but you notice that we have documents that we put into protected S3 environment, which is really just a data storage environment. We can then use serverless functions to be able to call textract, which we just talked about. So basically extract information from those documents, and then we can use other kinds of environments like ChromaDB, for example, in order to store information, which is the vector database. We didn't really talk too much about that, but that's your knowledge base. And then you can use it for retrieval augmented generation capabilities by interfacing then to Bedrock below. So these kinds of frameworks and architectures allow you to be able to then create a chatbot, which is on the right-hand side. So that's really sort of simplicity. There's also something called Health Scribe, sorry, and it's a HIPAA eligible automatic note generation. So we talked about this earlier. So these are some of the things that allow us to be able to listen to conversations or use transcription in order to be able to create clinical notes and notes that can be used as part of the patient record. So important parts of being able to apply generative AI within this environment. So some of the top use cases that we think through are reducing documentation time, because certainly in the healthcare space, we know that there's a lot of documentation, which is great. And it actually lends itself very well to this generative AI world because of the fact that we document things and we talk in human language. Large language models are specifically well tuned to being able to understand that. And so we can reduce our documentation time. We can boost medical and transcription efficiency. So again, expediting this capability by taking advantage of some of the other, like, for example, text recognition capabilities, and becoming better at that in order to be able to then allow us to create a knowledge base with a high degree of confidence that we can then use to do things like interact through chatbots. So it really allows us to be able to sort of move faster within this domain with a high degree of confidence. And then we can also create patient-friendly consultation recaps, for example. So if you're recording or transcribing the interaction, then you can summarize it, and then you can base it off of what are the kinds of things that that we would take from our knowledge base in terms of these are the best responses that typically patients would align to and that you would expect it to be able to end with. And you can ensure that every interaction includes a description of maybe what a prognosis might be, and then potentially what next steps and action steps might be after a prognosis. So you can ensure that all of the steps are followed, which creates consistency for you. So here, transcription features again. So you record, you can record this capability, then it basically takes you, shows you what the text looks like as it's generated. And then it from there, you can either edit it or modify it, but then it will go ahead and summarize it for you. So again, really powerful capabilities. Now, all of this is really wonderful, but as we think about it within the context of healthcare, or even I'll call it the overall enterprise in general, there are always challenges. Challenges will be related to security and compliance, bias, or potential ethical uses and harm, transparency and trust, error and loss, or excuse me, or even things like responsible automation. How do we take advantage of the fact that we can automate these capabilities without necessarily losing control of what it is that we really want to do in terms of monitoring? Like, we don't end up making recommendations that are not supported by the current thought process within either the healthcare organization or even according to maybe current medical doctrine. And then cost management, of course, is always going to be a challenge at the end of the day. So these things cost money. They take a lot of power. They take a lot of compute in order to be able to perform them. So within this context, there are a lot of shared challenges, and then, but from that perspective, there are a lot of ways that we can mitigate that risk. And so we talk about the different ways that we can approach this. And many of the concepts that I already just talked about, or capabilities that AWS provides through Bedrock and through some of the other bespoke products that we described, like HealthScribe, it allows us to be able to then address some of these issues and challenges to make it easier for us to move and then to feel comfortable with the fact that we're addressing some of these challenges as we move forward. Clearly, this is an evolutionary market, so this will continue to evolve over time. So what we want to do is make sure that we take advantage of the fact that we are continuing to evolve our modern data platforms or the data assets that we have available by using things like HealthLake, or our modern application environment is scalable and robust, so that it allows us to be able to deploy new applications as we need them. And so if you bring this all together, then you can create really this ecosystem of productivity within the organization to take advantage of new features and capabilities as they may come out, or just in introducing new technology and capabilities into an existing environment, and then taking advantage of the operational efficiencies. And that's really kind of where we want to go. So how do we get started? So one way to get started in this case is we can do one of two things. There are packaged applications, and we talked about a few of them, like HealthScribe, for example, that you can say you can start getting going with AI by taking advantage of component pieces of AI that's already available to you. Or if you're looking to solve problems which are maybe more robust and more organizationally impactful across, the healthcare, your healthcare enterprise, there are ways to be able to do that. And normally, what we see works the best is really just aligning to what's called an MVP engagement environment. So basically, you think about what problems you're trying to solve. How do you identify what they might be and what the impact could be? So this is in the value creation model. And then do quick MVP implementations, and it's a lot easier to do now, especially with the tools and services that AWS provides to us. We can show viability within a short period of time, and then you can move it into enterprise adoption or use case. So these kinds of things you can do in months. For example, you can try out some ideas and capabilities, and then ensure that they're going to pay dividends for you within the organization, or at least meet expectations in terms of what the ultimate objective is. And then you can take those things forward and govern them and manage them over time. So this approach works really well in terms of allowing us to be able to get up and running fast without a huge investment upfront in order to move forward. So those are really important characteristics. So if you're ready to take the journey, scan the code, contact us. We'd be happy to talk to you about it. We will work with you in AWS to be able to understand how we can best get you on that journey.